Hi, Jordan.
Hi.
Hang on, I'm inviting a few other people in right now. Hi, Aaron.
Alrighty.
Hi, Ethan. Hello, Jack. Hi, Trenton. Okay, so Jordan, start from the beginning.
Hmm?
Do you need me to start from the beginning, like how to do the survey project?
Oh, yes, please.
Okay.
Oh, wait, Ms. Grossel, is this just for the survey?
This is just for the survey project, yeah.
So, wait, where can I get help for the homework?
We will do that tomorrow in class.
So it's cool if I don't finish the actual homework part?
So the notes should be done before class.
Yeah.
You can do just watching the video, and then the actual homework, I'll take questions during class tomorrow,
Okay.
and then it'll be due by the end of the day tomorrow. So like, midnight tomorrow night kind of thing.
Okay.
Okay.
Sweet.
Okay.
Sorry.
No worries.
Later.
Bye. Okay. So I'm going to start by sharing the document that talks about the project. So can you see the design your own survey project document right now?
Mm-hmm.
Okay. So you will actually make sure you go through and do each part. In class, when you weren't there, we talked about this part 1 here, and everybody kind of checked in on that first. Hang on, it looks like I've got a couple people waiting to get in again. Okay. So for this first part here, you figure out what it is you want to ask about. So that's this select characteristic of interest part. And this is the part that you should have kind of done already, because you should have already done your poll at this point, right?
Yeah.
Okay. And then you've got your question, the population and the sample. So if you have results already, then you would have your sample right now. So your sample is the actual people that responded. So a lot of people ended up doing an Instagram poll.
Yeah.
And so then your sample is going to be whatever group of people responded to your poll. I would think for most of you guys, it's probably going to be something along the lines of, Sonoma County teenagers or El Molino students or something along those lines. If you could say, everybody that responded to my survey were all juniors from El Molino, then you could say your sample is juniors from El Molino.
Okay.
Yeah, except you wouldn't say all juniors, you would just say the people that responded to your survey. Okay, so again, the sample is just the people that actually responded to your survey. And then your population is a description of who those people represent. So I kind of had that backwards before. The population then would be like all juniors at El Molino, whereas the sample would be the juniors that actually responded. If your sample does include like anybody from Sonoma County, including teenagers and adults, then your sample would be the 120 or the 30 people that responded to your poll, and then your population would be all Sonoma County people, or all Sonoma County people within the ages 13 to 25 or something along those lines.
Okay, so the sample is the teenagers.
It's just the people that responded though.
Okay, and then the population is everyone. So like I had 130 some odd people respond or whatever, but the sample is just the people who are in a certain category.
The sample is the 130 people that responded to your poll.
Okay.
And you would probably give some details about who that would include, the type of people that is, whether that's, El Molino juniors or, just anybody that lives in Sonoma County. It could be anybody that lives in the United States. And then the population would just be, you know, like a bigger a bigger thing that contains everything that that sample represents.
Okay.
So do you want to clarify what you have and see if you got that?
Yeah. Let me see here. Wait, say that again.
So your population is going to be everybody that your sample represents.
Yeah. So I did pepperoni or cheese on pizza. And 132 people saw it. But I guess not all of them voted. That's weird.
So then you should see how many people picked pepperoni and how many people picked cheese.
Yeah, 42 people picked pepperoni and 26 people picked cheese.
You said 42 and 26?
Yeah. And then.
So that means you got a total of 68 people that actually responded to your survey.
Yeah.
And later when you get a chance to, you know, if you're able to see who that was that responded, if you can see that those were only, you know, El Molino students that responded, then you could say your sample is, you know, 68 El Molino students that responded to my Instagram poll. That would be your sample. And then your population would be something that those 68 people represent. So like all El Molino students.
Okay.
Okay. And then the next piece here is describing your method for choosing your sample. And so we talked about a bunch of different sampling methods. And so you would want to use one of those to describe the sampling method. And for your Instagram poll, that's probably, I think I decided that was going to be a convenience sample. No, that's a volunteer sample because they're choosing to respond to your survey.
Okay.
Okay, a volunteer sample. If somebody were to just ask, you know, like family members they had in contact, that they were in contact with, then that would be a convenient sample because those are people that they actually have contact with, that actually get it.
Yeah.
And then potential sources of bias might include, you know, just something that based on the type of people that responded to your survey, you know, maybe those people have never had pizza before, and so they might have bias. Or maybe the people that responded were all people that enjoy pepperoni pizza for some reason. You know, I don't know if there's some sort of reason why those people responded to your survey that may have created some bias in their vote.
So I still have to address it, even if there wouldn't be any.
If there is some sort of bias, then you should address it here. If you don't think there is, then you should say something about there wouldn't be any source of bias. Okay. So I'm going to put this out to everybody now. Does anybody have questions about part 1 before we move on to talking about part 2?
I'm all good.
Okay. So in part 2, where it says to conduct the sample survey and bring the results to the next class, that's where you're actually going to present your results. So that's where you'll say, you know, there were 42 people that said they preferred pepperoni and 26 people that said they preferred cheese.
Okay.
Okay. Anybody else have questions about part 2? That one's pretty straightforward.
Does this all have to be on like a poster?
No, it can just be in a document that you type up. It could also be on a piece of paper that you write up. The next part, you're supposed to have some sort of a graphical display, and there are ways to do those just in like a Google Doc even. And so you can do that directly in a Google Doc, or you could write something up and, you know, take a picture of it and include it in the Google Doc, or there's just, I mean, it's open-ended, however you want to do it.
Okay.
Okay.
Could I like take the same format that the instructions are given and just do like bullet points of everything?
As long as your responses are complete sentences, yes.
Okay.
Okay. Okay, so moving on to part 3 then, if everybody's good with parts 1 and 2. So in part 3 is where you are going to calculate your sample proportion. That's the p-hat thing that we talked about in class. So I'm going to switch over to something here. I think you guys can see this. You'll have to let me know because this is all kind of new for me. Can you guys see this?
Yes.
Okay, this screen here. Let's see, I'm trying to move it to a place where I can see it. Okay, so you can see where I've said, can you read this?
Mm-hmm.
Yes.
Okay. So in order to find the p-hat, that's when you just take the number of things that you're looking for and divide it by the total number of things. For the rest of this, it's probably easier to have your question be rephrased. So it says something more like, do you prefer pepperoni over cheese? And that way you can have a p-hat that's 42 of the 68 respondents said they prefer pepperoni over cheese.
Okay.
Okay, and so that's your p-hat, and so you can actually just, you know, use a calculator and divide that out. And turn that into either a decimal or a percent. So I'm going to round that up to 0.62, which would be 62%. And you should check that. I think I did it right, but you should double check it. Okay. So that is your p-hat. I'm going to go back to the document there. And then the next part, calculate the sample standard deviation. That's only if you have continuous data. And most people did not choose a question that was continuous. So for all of you folks that are here, do any of you guys think that you did continuous data? Do you need some help with that?
I don't really remember what that means.
Okay, so continuous data would be something where you have, you know, you ask them, you know, how many hours of sleep do you get a night? And some people responded 2, some people responded 10. And so you would have a sample mean rather than a sample proportion like I just did with Jordan. And that would be like the average number of sleep per night. And then you would then have a standard deviation for the results from your sample if your data was continuous. So it's when it's like a range of numbers.
Yeah, I don't have that.
Okay. There, you guys can hear me again, right? I think I accidentally muted myself. Okay, so anybody need help with the standard deviation?
Yeah.
Yeah, so do you have continuous data?
No, I don't, but.
Okay, so if
So
you don't have
to do that?
continuous data, then you do not need to do the sample standard deviation.
Okay.
Okay, so is there anybody that did continuous data that would need help with that?
Continuous is like yes or no, right?
No, that's the categorical. I know Jack just jumped back in. So Jack, what I just explained is the continuous is the, if it's like a range of numbers. So like the hours of sleep that you get per night or something like that. Most people did categorical where it's yes or no.
Yeah.
Or cheese over pepperoni pizza. Okay. So then the next piece here in part 3 is to create the graphical display. I've seen some people that have turned them in that found ways to do a normal distribution based on your sample. You could also just do something that's like a circle graph or a bar graph or something like that. So like a circle graph would just show, that 62% is shaded red for the ones that choose pepperoni, and then the other, would it be 38% that chose cheese? Maybe that's shaded in yellow for the percent of people that chose cheese. So some sort of graphical display that just, it's kind of a nice visual to show the results of your survey. And then this last piece here in part 3, stating a conclusion about your sample based on your graphical display, is just saying something along the lines like people preferred pepperoni. 62% of people preferred pepperoni over cheese pizza, that kind of thing. So I think I'm done with part 3, unless anybody has questions on part 3. Yes, Jack?
So I was wondering about the source of bias, if you already went over that. Sorry.
Back in part 1 there.
Yeah, sorry.
Okay. So that one is, it kind of depends on who responded. It kind of depends on what your question was.
Like I did a poll on Instagram, and it was like, do you normally use a plastic or reusable straw? So
that could definitely have some bias then. If you're able to see who it is that responded to your poll, you might be able to say that, you have more followers that tend to be more, environmentally conscious.
Yeah.
Because we live in West Sonoma County. And so there's likely to be some bias in my results because of that. So something along those lines.
Okay. Thank you.
Mm-hmm. Okay, moving on to part 4, if everybody's good so far.
Mm-hmm.
Okay. So then in part 4 is where you create your confidence interval. And so I'm going to switch you guys back over to my document camera here. I'm going to show you guys this. So this was something I gave you guys in class. If you want to refer back to it, it was from lesson 2.3, confidence intervals and population proportions. So this is on the back of that. And I am recording this. God, I hope I'm recording this. I think I'm recording this. So you could go back and watch this if you needed to look at this again. But the idea here is, so for this particular example here, that 78% is the p-hat. And so like when we were working with Jordan's number, Jordan's p-hat was 62%. And so in order to calculate the confidence interval, you first need to figure out the standard deviation. And let's see, can you guys see? You can see when I'm pointing. Oh, you can't see the part I wanted you to see. Okay, so this right here, this formula right here, is what you will use to find the standard deviation for the population. And so like Jordan's 0.62 that we had from his p-hat there, that's what's going to go in for the p-hat right here. So instead of the 78, the 0.78 that they have there, that'll be a 0.62 that Jordan will put in there. And then and then times the 1 minus his 0.62, and then divided by the n, which is the sample size. So in this particular example here that we did, it was a survey of 200 adults. And so Jordan's sample size was 68, because that's how many people responded to his poll. And so he would have a 68 down here. Do you guys want me to say that again?
So is that to get the confidence interval?
So this is the first piece of that, yeah.
Okay.
So to get the confidence interval, you're first going to need to figure out this number here, which is the standard deviation for the population. And then I'll talk about what we're doing down here with that down there. Okay, so again, for Jordan, it's going to be the square root of 0.62 times 1 minus 0.62 divided by 68. Everybody good with that?
Yeah.
Okay. So then you'll get a decimal value for that. And then I would turn that decimal value back into a percent. Now, if you had continuous data, you're not working with percents and you would not turn it back into a percent. But you guys, I think it sounds like all are using categorical data. And so you would be using this p-hat formula. If you did have continuous data, if any of you guys do have continuous data, you would be using this other formula down here for the standard deviation for the population. So just keep that in mind. If anybody needs me to talk about that, I can, but it sounds like nobody does, so I'm not going to unless somebody requests specifically that I do. Okay, so now that we have the standard deviation for the population, and Jordan, have you calculated yours by any chance already?
No, I don't. Oh, let me go grab a calculator.
Okay. Well, I was just going to use that as an example to kind of talk about this. But if not, you can just follow what I'm doing here and do that later. Okay, Jordan?
Okay.
Following what I'm doing here. Okay. So that 78%, which was the p-hat, and I've got it as a percent value. 78 is back as a percent, not as the decimal anymore, right? So the 78, I'm then going to add and subtract 2 of those standard deviations. Okay, so I take this 2.9 and I multiply it by 2 and I see what that comes out to be. So again, whatever 2 times that standard deviation is. So in this case here, what is that, 5.8, I think. And then I'm gonna take that 5.8 and I'm gonna subtract it from 78, and that gives me the 72.2. And I'm gonna then add that 5.8 to the 78, and that gives me the 83.8. And so that means that my confidence interval goes from 72.2 to 83.8. 72.2 to 83.8. So that is my 95% confidence interval. And I'll talk through how I got that again, just in case anybody needs to hear that one more time.
So the 78 was the p-hat, right?
Correct. The 78 was
it's
the
just,
p-hat.
It's kind of hard to see, but it's all
yeah,
pretty bad quality. But
I know.
Yeah.
And it moves and stuff. Sometimes if I zoom in, that might help a little bit. But
so you take what you got from that equation and then you subtract plus or minus the
2 of those.
2 of the p-hat or 2 of
No. So it's this right here. I don't know. Is it any easier if I'm writing on the paper here? Can you see that any clearer?
Yeah.
Okay.
Yeah.
And is it better even if it's in color?
Yeah.
It's better, but like it doesn't really matter.
Okay.
I don't think.
I will use the color.
Okay.
Because I got a nod that it might be a little bit better. Okay, so it's the p-hat value and then plus or minus 2 of these standard deviations, which aren't on here. I'm gonna put SD for standard deviations. So in that example we looked at there, that was the 78, which was the p-hat value, plus or minus 2 of the 2.9s. And the 2.9 was that standard deviation that we calculated using the p-hat formula. And then that turned into 78 plus or minus 5.8 because 2 of the 2.9s is 5.8. And then what I did was I did the 78 minus the 5.8 to get the 72.2. And then I did the same thing, but I added the 5.8 to get the 83.8. Okay, so that's the bottom of the interval and the top of the interval. So then the interval ends up being 72.2 to 83.8, and those are percentages. Okay, how are we doing with that?
Good.
Okay. Okay, so everybody's good with the confidence interval then?
Mm-hmm.
Mm-hmm.
All right. So then if I come back to the document, that's the first part of this. The second part of this, using statistical significance to make inferences about your populations. Because we got an interval, and I don't know if, Jordan, you've already calculated your interval or not, but I'm going to guess that it's going to be somewhere between like 50 and 70%, just because that's around the 60%. Okay. So let's just say Jordan's confidence interval was 50 to 70%. You could, this would be, remember when we talked about the What a Water survey in class, where What a Water said that their water tasted better than normal tap water. And if that wasn't true, then if they conducted a survey, then it should come out that 50% of the people preferred What a Water, because if it doesn't taste any better, there's not going to be a difference in the way people respond. You'd get half that like What a Water and half that like the tap water. So depending on your question, there may be the same kind of 50% value, which is kind of a mark of if there's not a difference, you know, in the cheese and the pepperoni, why people would prefer cheese over pepperoni, then you could compare your results to 50%. You know, other people may have asked a question that has, you know, data that exists in the real world, and so you might compare it to those numbers instead. But I would say for most of you guys, probably compare to 50% here. So again, this is part 4, this using statistical significance to make inferences. And so, let's see, hang on one second.
Wait, really quick, for the confidence interval, do you use the percent that you get or the decimal? Like when you multiply it from the p-hat?
Okay, let me go back to my screen here so that I can talk about that. My confidence interval I have back in percent form, so not as a decimal, but as a percent.
Just wondering.
Yeah, I just think it makes a little bit more sense that way. But if everything is all in decimal all the time, then you could leave it like that too. That would be okay. Okay. So now we are talking about the statistical significance to make inferences about your population survey. And that's what I was talking about. Most of you guys are probably just going to use 50% for that. So like Jordan's, let's say his, like I said, let's say his confidence interval was 50 to 70%. Well, that just barely has the 50% in it, right? And so because 50% does fall within that interval, you would say there is not statistical significance.
Okay.
Okay. And I'm going to go back to my document camera real quick, because here, if I compared the 50% to this, is 50% in that interval there?
Sorry, what?
So my question is 50% in this interval? Does 50% fall within that interval?
No.
Right, because the lowest number here is 72 and 50 is below that, right? So because 50% is not in that interval, then there is statistical significance. Is statistical significance.
And it's always 50%. So like if mine was, you said, say it's 50 to 70, I would say yes.
Right. Then 50% does fall within your interval. So then you would say that no, there is not statistical significance because 50% does fall within your interval. So is everybody clear on that? Because that's a little bit tricky because it's like backwards, right?
Yeah.
Okay. And so what that means is your results are significantly different than just if it had been 50-50. Now let's just say that, you know, your confidence interval was 50 to 70, because 50 does fall in that interval. You would say that there's not significance because that does include the 50%. That's not significantly different, but it's pretty close, right? I mean, if that was the case, then that would be kind of right on the borderline, and it all depends on what sample size you used. That will make your confidence interval a much bigger or much smaller range. Okay, so is that clear for part 4? Everybody feel okay about that?
Yeah.
Mm-hmm.
Okay.
Oh.
Questions? Okay. The next part then is where you're comparing your confidence interval to your partner's confidence interval. Okay.
What if you don't have a partner?
Then you don't get these 5 points.
All right.
You could ask Google, you know, like ask the class if anybody else did that question, and see if somebody else did, and then you could compare to them that way. You could also, you know, put out another survey somehow, and just to create another, you know, and get another sample of 30 people, just to have another one to compare it to get those 5 points. Whether it's an Instagram poll or, you know, some other way, you could maybe have a parent or something ask on Facebook just to get some people's responses. And then you would have to then calculate the confidence interval for that particular result. So you could get those 5 points still, even if nobody else asked the same question as you.
Okay.
It's going to take a little bit more work on your part. Okay. So then you're comparing to your partner's confidence interval, and this is where you would look to see if your confidence intervals overlap or not. So I'm going to go back to my document camera here so that I could kind of talk about this. So this was one confidence interval. Let's just say another confidence interval came out to be like 50% to 70%. Okay. Do those confidence intervals overlap?
No.
You can see here the biggest number, 70%. There's nothing higher than that. The smallest number here is 72%. So they do not overlap, right? There's no numbers in this interval that fall within this interval. And so because of that, they do not overlap. So again, you would say no, there's no overlap. And therefore there is statistical significance in your differences, right? Which means that there was probably something happened with your, the sample that you asked compared to the sample that, you know, if Jordan's mom asks or something like that, or your partner asks. If there is not an overlap, then there is probably something, some sort of bias or something that created the statistical significance. Okay, most people are probably going to get similar responses, and so most people are probably going to have intervals that do overlap. Okay, and if they do overlap, then you would say because the confidence intervals do overlap, there is not statistical significance. Okay, which means that basically your findings are similar to each other, is kind of what that says. Okay. And again, if you are not quite there, if you don't have your partner's data to look at right now, you could always look back at this video later. Okay, so then the last part, drawing a conclusion, basically just kind of saying what it is that your findings you know, were. People preferred pepperoni. Talk about the biases again, talk about the results of, you know, your survey compared to your partner's survey results, and just kind of, you know, bring it all together. It'd be great to see 2 or 3 sentences at least here, kind of writing a conclusion here.
Okay.
Okay. So questions on any of the parts, anything there that anybody needs help with?
If there's no obvious bias and I just say there isn't any, am I going to get docked points because I basically skipped it or no?
Nope. Because you're not skipping it if you're saying, there's no reason for bias. Now, another thing that I didn't think of before, because you're talking pepperoni versus cheese, that could be a vegetarian thing. So, if people if your sample, so the people that responded to your survey tended to be vegetarians, that would have created bias. So if you're able to look at that just to see that, that could have created some bias. So that might be something to think about. So that's the kind of thing that I'm looking for in terms of bias is, what could have created somebody to say they prefer cheese over pepperoni because they don't like to eat meat, right? So that's the kind of thing I'm looking for there.
All right.
Okay. Other questions?
My data is like cats and dogs. Like, which one do you prefer? And if someone has an allergy, like to cats or dogs, would that be a bias?
Yeah. I don't know how you would know that about somebody unless you happen to know them. Yeah, you could say that was some sort of a bias though, but I don't know how you would know ahead of time who was and who wasn't, or, because they live in Sonoma County, they're more prone to allergies.
Right.
Me and my partner, we basically have the same data. Like,
Okay.
I don't know. I got 90% as my p hat. He got 92% as his p hat. So,
yeah, and that's pretty normal actually,
yeah,
to get similar results, because you guys probably asked similar samples. You probably asked a similar group of people, and so I think it's pretty typical to get similar results. You might address in the last part, the drawing conclusion part, that because we asked teenagers that live in Sonoma County, or whoever it is that you both asked, you might say, if we had asked teenagers that lived in New York, or if we had asked adults that live in Sonoma County or something along those lines, then that may have been different because blah, 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 right? So you can kind of talk about why there may have been, what could have caused some changes or some differences in your results.
okay.
Okay. Anybody else? Questions?
Could you go over how to find statistical significance just one more time?
Okay. So you are talking about part 4 then?
Yeah, part 4, the second bullet
Okay.
point.
So what I said there was, it's likely that most people would be comparing that to 50%. This is where, with the what a water example, if there was not a difference in the taste of water, then 50% would say they prefer what a water, and 50% would say they prefer tap water. So it kind of depends on what your question is. With Jordan's, that was, people prefer pepperoni or cheese pizza. There isn't a particular reason why people would choose pepperoni over cheese. And so I would use the 50%. And so what I said was most people probably will use 50% as the number that you're comparing to. And so that's where you'll see, is 50% within my confidence interval or not?
So if it is it not statistically significant?
Correct.
Okay.
Right. And so here the 50% was not in it. So there is statistical significance. But if I took a number that is in there, so let's say, 75%, right? 75% is in the interval.
So we're just using 50%?
Unless there's a reason why you would pick another number. Yeah.
Okay, well, I don't think there is. So.
Yeah, most people will probably use that. So again, because 75% does fall within that interval, there is not statistical significance. Which means that basically what that's saying is, like with the pepperoni and the cheese thing, that, if the 75%, or yeah, if the 75% is in fact in the interval, then there's not statistical significance, which means that, you know, that's kind of what you expect it to be. You would expect that. There's nothing about these results that make you go, oh yeah, people definitely do prefer one thing over the other. People definitely do prefer What a Water over tap water. Okay, if there was statistical significance, then that would make people go, oh, maybe I should buy the water instead, or maybe I should buy pepperoni pizza instead. Okay.
Okay.
Other questions? Okay. Well, like I said, I'm pretty sure I recorded this. And so you should be able to access it afterwards if there's anything you need to refer back to, but I hope that helped.
Thank you.
You're welcome. Okay, and so I will see you guys tomorrow. You guys all got the Google Classroom announcement with there's a video you're supposed to watch, there's notes you're supposed to take. The notes should be turned in before the Zoom meeting tomorrow if possible. And then there's an assignment that you can try to do before you come to the Zoom meeting. And I will address any questions that you have on that assignment while we're in the Zoom meeting.
Do I just take a picture of the notes or something?
Yeah, so what I wrote is actual pictures are really hard for me to see on Google Classroom. So if you can figure out how to scan them, and you can do that with your phone. I know because I have an iPhone that if you go into the Notes app on your iPhone, there's a way to scan documents in there. And people that have done that, it's so easy for me to see those on the computer. So that works really well. And then if you don't have an iPhone, I did put in the document that I sent that kind of has, you know, the step-by-step instructions for how to do the distance learning thing. I put a couple of Android apps that you could use to scan things. The pictures work. And so if you can't figure out how to scan it, do the picture. It's just really hard for me to see details and to see the bottom of the page for some reason. So maybe if you end up having to do a picture, take a picture of the top of the page and then the bottom of the page separately or something like that. So anyway. Okay. All right. See you guys tomorrow then?
Yeah.
All right.
Goodbye.
Okay. Bye, everybody.